What I want to, we'll go ahead and get started, and I know there may be a few more that are gonna connect here. I went ahead and put the meeting ID and the passcode in on the chat on this particular one. If you can see it on your screen, just in case you're having trouble connecting with the audio, I want to make sure that it's not confused with the one we had earlier today that got canceled. So some of the things we're going to cover today is going to be on our electrical work practices. And I wanted to be sure that you guys hear me on this part, and wanted to make sure and clarify this is not an NFPA 70E training. Those trainings should be done by a licensed electrician, somebody that's got at least a journeyman license and maybe even a master to do those. And those take about 8 hours, maybe even longer. So if you're wondering what we're going to cover today, we're going to cover a lot of the safety and safety work practices for most of us that deal with minor electrical issues and minor things at the work site having to deal with electricity. And we're going to cover all the details surrounding that. And I have sent out a copy of a PowerPoint. And for those of you that have video capabilities, I'm going to share that slide with you here. And if you have any questions as we go along, please unmute your phone and whatever, and let's have a discussion about whatever you may have questions about, or if you want to elaborate some more, please chime in. I want you to participate. And I know that Keith and I would prefer that you maintain your phones and your connections muted, but if you want to participate, please unmute and make a comment. I really appreciate that, and I want to include everybody on this. So I've shared my screen there with those that have video capabilities, and our learning objectives today has to do with basic electrical terms, what the hazards of electricity really are, some safe work practices, and some best practices that I'm going to throw in verbally, at least. And there are some best practices that I've interjected in this presentation. And we're going to talk about some of the real world things that you see out there. Some of the electrical terms that we'll be covering for those of you that are not electricians. You know, we may discuss current, which is actually measured in amps. And everybody's heard about, yeah, I have a 15 amp circuit at my house. I've got a 15 amp breaker that I've had to flip. That's what they're talking about, is about 15 amps or 20 amp breaker that you see in residential areas. Resistance is measured by ohms. And not going to spend too much time on voltage. Voltage is, of course, the electrical force that's coming through there. Oftentimes you'll see things that are relatively safe that are out there, like cattle fences, cattle guards, things that have electrical fences on them. Those are extremely high voltage, but extremely low amps. They want to get somebody's attention, but they don't necessarily want to kill that animal or that person. So that's, the lower the amps, the better off you are. So we'll talk about some of these things. Conductors, materials that have little resistance to electricity. That includes ladders, scaffolding, and a person if they're not properly wearing their PPE. You can be a conductor. Insulators are materials that are highly resistant to electricity, and that's why you would have situations where you've got ladders that are made out of fiberglass, things like that, to prevent that and make that an insulator that you're standing on. The more rubber and fiberglass and dry wood you can put between you and something that might be a conductor, the better off you are. I have seen the cases that I've seen on electrocution cases have all come from Scaffolding and ladders where they were using a metal ladder rather than one that's made out of fiberglass or other materials, and got a little too close to the electricity. So grounding is the process transferring the discharge, of course, directly to the earth. And that's having a grounding plug, grounding situation. Of course, a person can be a ground too.
That's because oh, is it?
Electrical injuries. Somebody, if y'all wouldn't mind, go ahead and mute your phones or mute your connections. So I appreciate your input. And if you need, please speak up. Common types of injuries and accidents associated with electricity include burns, of course, electrocutions, electric shocks, and falls. That's an interesting concept we need to discuss for just a few minutes, is why electrical injuries increase the likelihood of a fall. And we'll touch on that a little bit more a little later. There's some discussion on that. And of course, arc flashes are horrible circumstances. I'll describe one that that happened here locally nearby where I live, within 10 or 15 miles. We'll discuss that just a little bit, and I'll tell you where they went, what they were doing right, what they were doing wrong. Burns, that's where electrical burn is to the skin. Burns that occur when you get a little too close to electricity and it heats up the moisture in that body contact, it will cause a burn. Usually that's something that should be avoided at all costs, obviously, but electrical burns can be severe. And the problem about electrical burns is that oftentimes the extent of the injury is not known for days. It can seem like, well, yeah, he had a little bit of a burn on the end of his finger, and then a week later, that finger's dead and black. Looks like it's had frostbite or something on it. And so oftentimes it's really important to go get medical attention if you've had something that looks like more than just a minor electric shock and maybe come closer to an electric burn. Very important. Electrocution. Let's make sure we got our terms correct here. Electrocution is generally a fatal shock. This means somebody's been electrocuted. Don't ever tell somebody, oh man, I've been electrocuted 2 or 3 times. No, you haven't. You've had some electric shocks, but you've not been electrocuted. If you've been electrocuted, you're not here anymore. So the terms are important. Now let's talk about some of the effects of electrical current on the body. And we're talking milliamps here. And I've got a chart up here, and I'll just describe it to those that don't have video. But you have about 1 milliamp. You can feel a faint tingle if you're grounded and you touch something that's got 1 milliamp in it. You're going to feel a little bit of tingle. 5 milliamps, you will feel a slight shock. Most people would jerk their hand back, jerk their foot back, jerk whatever's hurting you at that second, and you can jerk and you can pull back at about 5 milliamps. Now, once you get up to the 6 to 30 milliamp area, that's where you run into problems where you get a painful shock, and I mean, it hurts, but it's very possible for you to have muscular loss of control, which means you grabbed a hold of something and you cannot turn loose. Now, if you find a situation where you can't turn loose of something, that's a real serious situation, and you're only talking between 6 and 30 milliamps. This is not that much electricity. Okay, let's talk about, you get up above that and you start getting up into the 50 to 150, and this is going to blow you off a ladder. This is going to knock you. This is going to make your arms twitch and your hands twitch for several minutes after being hit by that. And then it goes up from there. It only takes 1,000 to 4,300 milliamps, which is around 1 amp. 1 to 4 amps is enough to cause ventricular fibrillation, which means your heart goes out of sync, and if something's not done about it real quickly, you die. And anything over about 10 amps, cardiac arrest is very possible. It's not probable, but it is possible. And I'll tell you a little short story about this. There's a meat packing plant not too far from where I live, and they had a custodian that was in there cleaning between shifts and running a floor scrubber. The floor scrubber had a little bit of water with it, and of course everybody knows that a meat packing plant's going to have water and the floor is going to be wet. But the grounding plug was gone off of the cord that he had plugged into the scrubber. They found him about 4 hours after they, this was right at the end of a shift on a weekend. They were going to shut down on the weekend. Somebody went back through, walked through, found him laying on the ground. And he had been hit by 110 volts, 15 amps. We're talking a regular 110 volt outlet on a regular wall hooked to a regular deal, but it was not GFCI, because generally in this particular area did not have a whole lot of exposure to moisture. But his particular process sure did, but he did not have the grounding plug on that device. It was broken off or whatever, and it hit him just right, killed him. And the issue was he was not able to let go of that device once it hit him. And he was not able to recover. Nobody was around, and they found him dead a little while later. So just to give you an idea, can 110 volts straight out of a wall kill you? You bet it can if it catches you right. So, and there's a lot lower electrical amperages that can do that to you. And I just want to make sure we all understand the seriousness of this situation. Electric shock is when you've been hit by something. You don't die generally. My son is an electrician. He's a journeyman. He's been popped multiple times. Some of that is, some of that, and as I talk to him, and he and I visit about this quite a bit, and we talk about the mistakes that he has made. And we'll talk about that in a few minutes, but I think you follow the rules, and you follow procedure, and you take a few precautions, the likelihood of you coming up with electrical shock or an electrocution goes down greatly. Okay, the severity of these shocks will depend on the amperage that you're in, but even that, a regular 110 volt outlet's enough to get you. So let's talk about some of these things. Electrical work is commonly done from height. So let's talk about falls for a minute. Electrical work, a lot of work. My son works on ladders all day long. Those ladders have to be fiberglass if you're doing any electrical work at all. And you have to be paying attention when you set them up. But this, if you're not setting this stuff up right, and you personally become a conductor for whatever reason, and it hits you, you often fall off of whatever you're standing on. Even at 110 volts, I've seen people fall off ladders, scaffolding, the edges of roofs. Matter of fact, the interior part of a roof, I saw somebody, a situation where somebody
Not
had
at all.
gotten
Not at all.
hit
No,
with the roof and
Friday's fine. I'll come down Friday morning. No problem. All right, thank you.
To avoid these types of electric shocks and these falls, it's critical to follow the procedures and not get that electrical jolt. Okay, arc flashes and blasts are the ones we usually hear about. Those are just catastrophic. There's nothing worse than an arc flash. Worst case I ever saw of a guy that should have been a pile of a bucket of goo standing there. Should have been killed instantly, and I don't know how he wasn't, but he was called into, first of all, he was called out on something that he was not qualified for. He shows up, and of course, your first indication that he's doing something wrong is he's got a fuse that is 20 inches long, and about 4 inches across that he's checking. He opens the door on the fuse box, and here's his fuse sitting there. It's an absolutely gigantic fuse. And he takes a regular 600 volt tester and sticks it up there to that without any PPE on. And he had an arc flash, blew him halfway across the room. And he's lucky, but he actually ended up with very little damage. He's, to this day, he's still having a few issues with his hands and his arms and his feet due to, he has some permanent disability and all that, but he has his life. And I tell you what, out of 1,000 times, if that were to happen, 999 of them would have died and only one would live. And this guy happened to be the one. He was so lucky. I can't tell you how lucky he was, but he was called in. So here's a note for a supervisor. Don't call somebody in to do some testing and do some checking and do some things with electricity that's not qualified to do that. That's because they don't follow rules, they don't follow procedure, they don't follow PPE. Arc blasts, arc flashes are absolutely a horrible situation. It's an intense heat, bright light, and concussive force. Out at my prior employment, we had a remote facility that was about 15 miles out of town, and a contractor came on site and did some work for them with some high voltage work. And he created an arc flash, and there were some guys working approximately 5 miles away. Some of our crews were working about 5 miles away on another project, and they heard that arc flash and that arc blast. And that's 5 miles away. That's how horrible an arc flash is, and how deadly they really are. So, you know, electrical work obviously can cause fires. It's usually from temporary wiring issues, maybe frayed wires, cords, things like that, explosions. We just talked about those. But you hear about all these horrible issues with range fires, wildfires going on. Those are often electrical issues that are caused with bad wiring. Don't be part of the problem. Don't cause it out at your work site. Make sure that you've looked your equipment over really well, and you don't be the person that causes a fire or an arc flash or an electrical jolt to an employee. The common hazards you run across: bare damaged wires. This picture shows a picture of some stuff coming out of a wall and how bad it gets at some. I tell you what, my son sends me pictures all the time of some of the stuff he sees out on remodels, where even if it was an electrician that did it, obviously they were shortcutting their methods, shortcutting the rules, and shortcutting codes. And when you shortcut all those methods, they leave hazards for people that come in later to do the work, such as Echelon coming in doing things, or one of your subcontractors. It's important that if you've encountered problems like this on the job site, that you inform your subcontractors, hey, we've run across some pretty crazy things on this job site. We've seen some crazy wiring. We've seen some stuff, so make sure that you do not work on an energized circuit. You have to double and triple check your way through that. Exposed electrical conductors like that create shocks, burns, and fire hazards. Missing ground pins. I was just talking about that on that guy's situation. You've got to stop on a fairly routine basis and check your extension cords and the connector cords for your powered hand tools. Some of your powered tools, look at it, and I've got a picture here of a ground pin missing on those. You cannot use those on a job site. It's an OSHA violation. It's an instant OSHA violation when someone walks through and sees that. I promise you, for some reason, they focus on this because it's so easy to check, and there's no excuse. for not having this repaired and having this situation taken care of, because the grounding pin off a 3-prong plug is gone.
Can
Make
I
sure.
add something here?
Yes, go right ahead.
A lot of workmen that have a double insulated tool, the plug will become defective and they will go to Lowe's or Home Depot and they'll buy one of these plugs and they'll put it onto that tool and they'll tell you that everything is okay. But a double insulated tool, if you put that kind of plug on it, you're bypassing the safety of that tool by doing that. So, as you're walking the job and you see a tool that has a brand new cord on it, check the label on it and see if that tool is double insulated. And make sure it has the proper plug on it. Well, the proper plug would be to replace the whole power cord. And that's all I got to say on that. We understand what we're talking about here?
Thank you, sir. Appreciate your input. That's a really good experience, and you're giving best practice recommendations. I really appreciate that. Thank you.
You're welcome.
Oftentimes you'll see new cords on a lot of things. Extension cords, you'll see people, and we'll talk about some of those things in just a minute. I've got some examples here in a minute. But you see improper cords being used. You'll see important to use the proper cord for performing that electrical work. Make sure they're the proper gauge. You have to have the higher gauges for, especially the longer runs you have. The higher gauges are really important. They're heavier, granted, but they're usually, the heavier gauges are also more durable. If it trips a circuit breaker, you have to stop immediately and figure out what the problem is. Only use cords rated for industrial use, not residential use. And these have much tougher jackets on them and connectors and pins, and everything about them is more heavy duty. Just make sure you're watching for that. You see a Home Depot tag or see something on there that you would recognize being a store brand, just make sure that they're using industrial grade cords. Some of the things that you do is you'll see, do not attempt to repair electrical cords with electric tape. I've got a picture of one in here in a minute that I took at a job site where the electrical tape was on a cord, and you just cannot, is it just not allowed. Above all, the qualified employees are the only ones allowed to repair cords. They have to be repaired according to the electrical proper procedures and codes. And the issues that you run into oftentimes is a repair in the middle of a cord, which is just not allowed. I have not seen an OSHA, and I'll put it this way, I've not seen an OSHA inspector accept that a cord is repaired anywhere in the middle of a cord. Now, I've seen him authorize and be okay with repairs for a new plug or a new receptacle on one end or the other, if it's done by a licensed electrician and you can prove it was done by a licensed electrician, then you're good to go. And that way you don't circumvent the requirements of the piece of equipment you're using, whether it's regular power tool or whether it's double insulated power tool. If the cord that is connecting it is not properly repaired on either end, it can cause an extreme electrical hazard on the job site. Paul, do you have any other comments on that before I go on? Or whoever was mentioning that earlier?
That was big. No, I think everything is covered there. Like I said,
Okay.
just as you're walking to the job site and you're looking at cords on tools, make sure you look at the label on the tool itself. Then make sure that the cord is the proper cord that needs to be on there.
Perfect. Absolutely perfect. Some of the improper use is running cords through doorways, windows, or walls. We're talking about almost completed functions. You really don't need to be doing that. Just be looking out for that and watching for that. When you have frame only up in a building, frames all you're dealing with, you'll see cords strung around a lot of areas. There's no problems with that. That's temporary. That's why you're working in that area. That's not a problem. Once doors, windows, and walls start going up, those cannot be strung through those areas. Watch for the attached cords to building surfaces like this one right here. With somebody that nailed it on there and bent the nail over, that's a no-no. Of course, completed job sites, especially when temporary people need, well, I got to have my computers up and running, and I've seen extension cords run through walls, through windows, some pretty crazy places, and they were just using it temporarily while the repairs were being made and the electrician had things going, but there's better ways to do that than run it through the wall. It's really hard to run it through the doorway because it just makes it susceptible to being slammed door on it or something like that. And then multiple extension cords all strung together is another issue that you see. That I see out on job sites, and also a big no-no. Power strips, obviously, can't allow those to be on a job site. They're not industrial or in an industrial environment. These home use or office use type power strips are not to be used on the job site. There's a small chart in here talking about how many feet distance you need between the power source. And if you're dealing with higher amounts of electricity, and we're talking about AC currents that start out at 50 kV and up, and that's a lot of voltage. But sometimes in industrial settings, you have some. I had some 350 to 500 kV at some of our power plants that I worked on. And if you look to the right on that distance chart, it talks about how many feet that you have to keep back from that area. If you have an area like that and you see painting markings, warning signs like that sort of thing, you got to make sure that that you stay quite a long ways from that stuff, because you're talking some high-end power. That example I gave earlier was primarily a problem with not having the electrical box marked with what the KV was in this box. By the way, it was in the 300 range. You're talking a lot of power, but this and this fuse was 4.5 inches across and it was 18 inches long. It was huge, obviously larger industrial setting, but it was nobody should have been within 20 feet of that without the proper gear on and having the proper certifications. Live electrical components in a panel can create serious arc flash hazards. And I always tell everybody, this is best practice. You walk by an electrical panel, the panel's open. It's time to stop and have a discussion about why this panel's open. Somebody's been in it, somebody's working, somebody's doing something, and they probably popped, triggered a breaker, and they keep having to go over to that panel. So eventually they just leave the door open on it. Just be real cognizant if you got that going on, especially on a job site. That means somebody's in and out of that box all the time. And you at least need to know what's going on and make sure that their work's not affecting other people working on the job site. Having a live panel while somebody else is working in there is not following proper lockout tagout. And it really creates confusion on the job site. So make sure that when you walk by an electrical panel and that panel's open, that you're working with, that you're talking to employees, and you're making sure everybody working in that area has clear understanding of what's going on. We had a really large arc flash not too far from where I'm at, and the ironic part of it is it occurred in the power company's new building, the new office complex for the power building here locally in my area. They were, a contractor was in there, and they were drilling a hole into a control panel into a panel box, and had not turned the power off. Actually, they had turned off the power earlier. Somebody came along and needed the power and went over there and turned it back on. Obviously, they were not following lockout tagout like they should have been. They were drilling a hole in there, and when his, first of all, you shouldn't be drilling into an electrical panel. If it doesn't have enough holes in it, you're not supposed to be putting more holes in it. So there were so many things that went wrong with this situation, but he drilled in there. Of course, when it went through the metal, he contacted a conductor inside that, and it blew the walls and the doors off of this room he was working in. This room was about 20 foot by 20 foot, and they had to replace all the walls in the room. They had to replace all the panels, and they had to replace all the steel doors that were on that room, because they were all damaged to the point, and there was 2 employees killed, 1 seriously injured. It was an ugly situation. That's because they didn't follow lockout tagout. So so what's the number 1 rule? You never work on a live conductor, ever. Always make sure power's off. Number 1 rule. GFCIs. Let's talk about GFCIs for just a second. Ground fault interrupters. There are ground fault interrupters that are oftentimes provided by the general, sometimes provided by subs on the job site from the main power supply. Oftentimes these are good. Check, make sure they're not tripping those. Make sure they're in good shape. They're supposed to protect the workers, and if they're constantly popping them, something's wrong, needs to be dealt with right away. The other thing I'll talk about on GFCIs is on a completed project, and any of your projects and any of your, of course, it's code, but making sure that anything that's within 6 feet of a water source has to have GFCI. In some regions and some codes and some locations, I've heard it mentioned that, oh, it's only within 3 feet. I promise you, you need to keep at least 6 feet from a water supply, water source where things can get wet. We're not talking about just a water pipe. We're talking about water source where you can get your hands wet, feet wet, water actually being discharged at that location. Must have GFCI. And of course, I put several different pictures of GFCI type pieces on here. Those of you that are electricians know exactly what I'm talking about. But for those that are not electricians and haven't worked around electricity all that much, if you pop a GFCI, make sure you've got, you look into the problem, you do troubleshooting. Don't go back and reset it and keep popping that GFCI. If it keeps triggering the GFCI, you have a problem that needs to be resolved. Get help. And you see a contractor, a subcontractor out on a job site that continually having to go back and reset GFCI, he's got a problem. He's got a big problem on his hands, and it may be his equipment, maybe his conductors, his cords, his extension cords. It could be anything. It could be a faulty equipment But if it continues to pop the GFCI, there's a problem. Needs to be resolved before they continue work. Anybody have any questions about that?
Hey, Jim, this is Keith. I want to jump in there on that, on the GFCIs. So what happens also is the GFCIs will actually fail after so many uses. So if it keeps tripping, sometimes it's that itself, not so much the equipment. So, but yes, it's very good to backtrack and go and look and see what it is. That's it.
Thanks, Keith. Anybody else? Very good. Here's some examples of some things that I've seen on the job site. You know, just by stopping and doing your inspections, you'll see these electrical cords, you know, the missing ground plug, the frayed cords, the ones that have been repaired, or maybe they've been repaired, like this one in the bottom right-hand corner of this picture. And if you don't have it, I'll describe it to you. It's a yellow extension cord that somebody had obviously replaced the end on. And just between the yellow cord and the
Pretty good.
female plug there, it's got a big frayed area. Those are the kinds of things you need to be looking for.
Hey guys, we need to mute phones. David Mendez, I think you need to mute your phone. Everybody else too.
Some of the safe practices, avoid using electric cords with equipment in wet environments. And I tell you what, this is very difficult to work with. And these are the type of situations supervisor needs to be involved and make sure that that when you do have to work in areas where there's potential wet environments, make sure that's discussed with the employees on how you're going to mitigate that hazard. Be sure you're having that communication. Don't leave it up to the employee to recognize that hazard and to work in it and make their own decisions. Have that discussion with your contractors if you're having a wet environment that particular day and what additional precautions they need to be taking. Be mindful about where cords are. If you walk in through a place and the cords all look good, but you don't like where they're placed, go ahead and mention it. It's worth mentioning to them because I ran across one yesterday at a location. I came up to a customer's location. There was a contractor there doing work. He had all of his equipment set up across the parking lot and how all his extension cords run across the parking lot. It was just before noon. Everybody was fixing to leave there and go to lunch, and they were going to drive across his extension cords. And I stopped and made a comment, and I thought I was, you know, I was trying to be really nice about it, but they didn't appreciate my comment. You know, when you're handing cords, moving hand tools, never use the cord to move the tool. You'll see this oftentimes more with people up at an elevated location trying to give it to somebody down below. They'll grab the end of the cord and lower it down through there. Don't ever do that. That causes problems, obviously. Don't pull, you know, pull on the plug right near where it's connected to the connector there. Don't grab the long cord and just pull on it. Don't use your foot to kick it out of the wall. That sort of things. That's exactly how the grounding plug comes up missing on those, is because people are not removing the plug correctly from its receptacle. 99% of the time they have to be, the grounding plug has to be replaced because they're not following this rule. Sometimes it's just bad cord. Sometimes just bad plug. It's going to fall apart, gets used enough. But most of the time it's because it's been misused. You know, store your cords and your tools up in a way that keeps them from getting damaged. I can't emphasize that enough. Keep them out of the sunlight. Sunlight damages the cords when they're being stored. So be sure they're stored in an area out of sunlight so that they don't deteriorate and start cracking. If you're working on a piece of equipment, follow the lockout tagout carefully. Do not work on energized circuits. Plugging and unplugging is one thing, but actually doing work and connecting conductors, doing any kind of connection Don't do it on a live circuit. And if you have any questions about that, talk to Keith about your lockout tagout procedures, because that means your lockout tagout procedure is not getting followed if you're working on a live circuit. There are some rare circumstances you can work on a live circuit, but you're talking master electrician, you're talking very rare, extremely rare situations. Those should not be done unless a lot of precautions have taken place. Power sources need to be identified. Breakers should be labeled properly. And that's funny because I've been living in my house right now for 10 years. I went to do some work on a wall switch. I was replacing it with a Wi-Fi switch. And I spent an hour trying to figure out which one of the breakers went with that particular, because the people that put the breaker box in didn't label it. So that took forever. I ended up messing up internet and disconnecting everything before I finally found it. So make sure if you find a breaker and it's not labeled properly, relabel it or add information to it, at least temporarily. Employees should know where the electrical disconnects are for any equipment. And this is, we're talking about equipment that are either, something like a pull device that disconnects the power. Some of your larger pieces of equipment that have larger power connections to it. We're talking 220, 440 to run a little larger piece of equipment. You need to know where these electrical disconnects are. Make sure you know how to shut it down and everybody around you know how to shut it down. You got to be able to pull that in case somebody has an issue. Do not block electrical panels for any reason. I find this a problem at both work job sites and after the work's been completed, and the tenant tends to block these panels with whatever materials, and you got to leave those open and accessible. So don't be part of that problem. Make sure that only employees that are working have been authorized to do so. When in doubt, you ask them. When you see somebody that's supposedly an electrician doing work and they're not following the rules, you're going to have to stop work for a second and make sure they're authorized to do so, or at least certified within their, do they have because what you just saw doesn't match up with their training. What's safe. You see somebody doing something unsafe, stop work and let's have a discussion. Don't work on live electrical panels. This is something that just shouldn't be done. I can tell you that the 3 or 4 fatalities that I have worked in my lifetime, I've been doing this 35 years, and I work the workers' comp side of things and the safety side of things for a larger organization and for other larger organizations. And I will tell you, every instance of an electrocution that caused fatality was because the employee was working on a live electrical panel or without having pulled the switch gear and isolated the circuit. That is basic information that has to be followed. If you want to live, you deactivate the circuit, follow your lockout tagout. If you want to go meet Jesus, work on a live one. That's my interpretation, and I hate to be straight and forward about it, but that's my take on it. Lockout procedures and specialized PPE must be used to reduce electrical hazards. I used to work for an organization that had some of that larger amounts of that electricity, and those big Tyvek suits or whatever they're called that protect you from larger voltage. And the guy had a 12-foot non-conductive rod that he used to turn equipment on and off with. I'm telling you, that's something to be observed one time. It'll make you respect electricity a whole lot more. You see somebody moving some larger electricity like that and turning it off and on. Big deal. But make sure the proper PPE is available and used. Watch your subcontractors on that. Make sure they're following all the rules on PPE.
Can I say
Excuse me,
something?
Jim?
Go right ahead.
Okay, Jim, this is David Holmes. In some of the buildings we work in, they're backed up by generators. So I noticed that you keep saying we need to disconnect the loads, but one thing that I think you're missing is on some of these facilities that are backed up, even if you cut them off, they can still come back alive on you. So you should be in a cow suit, have gloves that have good dates on them, wear a face shield, anything for the load that you're working on, and consider it to be hot all the time, even when it's off.
That's a very good point. It's exactly the same as always treat a gun like it's loaded. Well, you always treat a circuit like it's got electricity in it. If you treat it like that, you can reduce your chances of ever having electrocution, and that's an excellent point.
Let me inject something else about lockout tagout. I was doing an X-ray center, and we had 6 X-ray machines up and running. We were doing punch lists. Young electrician walked into the main electrical room and started flipping breakers on and off. So needless to say, he fried 6 X-ray machines.
Oh my gosh.
Now, it was not a life safety issue, but can you imagine the cost? And it's stuck with me forever about, if you're testing equipment, lock it out. Because somebody walk in there and just flip the breaker on and off, you can fry that piece of equipment. Lesson learned.
That is exactly what happened on that one that happened down at the local power company. Somebody went and found a circuit dead and walked up there and turned that and flipped it back on while the journeyman was out of the room, walked back in the room, didn't realize it had been re-energized, continued his work, and then boom, there you go. And that's
Jim, one more question or one more comment, excuse me. I just came off of a large project, and to keep people from messing with the electrical panels, we actually locked them. That way nobody could arbitrarily just go and turn on breakers or shut off breakers or anything of that sort. The only folks that had keys were actually the electricians, the superintendent, and myself as the project manager.
I would have taken one key out of play, and me as you as a project manager wouldn't have had one. It would have been the super and
The only problem is with him in and out of the job because of COVID and that. That's it, Jim.
That's an excellent point. One of the stranger things that I've seen is we had the county here local has a large fairground, and they were up doing some electrical work, temporary electrical work up on a pole. The county electrician was up there doing work, got electrocuted, unfortunately and it killed him. And OSHA came out because this was a contractor doing the work, not the county. It was his county facility, but it was a private contractor. So OSHA said, well, let's make sure that circuit's off, and let's run somebody back up there. I want to see what's going on. And it killed the OSHA contractor on the site. He also put himself in harm's way and got killed on job site. And it was the strangest set of circumstances I think I've ever seen in my life. Happened many years ago, but it was a situation that brings it back to light. No matter what somebody tells you, yes, I've got that deactivated, unless you've seen it yourself and confirmed it yourself. Just like I said, assume the gun's loaded, treat it accordingly. Anybody else have any comments? But I'm done with my presentation unless we have other comments.
good presentation. I really enjoyed it. I learned some things and brushed up on some things. Thank you.
Very good. So I will see you guys next month. And if I don't hear from you between now and then, you guys have a great holiday season. And
Thank you,
please be
Jim. I
careful.
just want to thank you, everybody, for joining us. Again, next month, the meeting will consist of 9:15 Central Time, and we will get that out. Sorry about the confusion, but we will work on that as our end here, my end. And Jim, I appreciate your participation in this. Have a happy Merry Christmas and Happy New Year. And I hope your family's doing well.
Thanks, Keith. Appreciate it.